welcome you all for joining this webinar on high-rise building design with construction stage analysis. Here is Master Akshay Magar, structural engineer at MIDAS IT. So I'll just begin with my presentation. So coming to the question answers, so you'll be able to see this question tab on your webinar window. So in between, if you have any questions, you can type your questions. I'll be answering in between, or else I will answer it at the end of the webinar. So let me start with the webinar. So about MIDAS 10, my presentation flow would be as such. I would be telling about MIDAS, what are our company background and the MIDAS family program. Then I will be talking about construction stage analysis. Then I will move on discussing with the column shortening and related issues. Then we will just look into some few more project applications where actual construction stage analysis considering the column shortening effect have been studied and undermined and designed and analyzed in MIDAS 10. Then I will go with the live demonstration by opening in the MIDAS 10 software and demonstrating all the capabilities with considering your high-rise structure. Then I will be talking about few more things about the features which are available particularly for the construction stage analysis. And at the end, I'll be dealing with the question and answer session. All right. So let me begin with the background. So about MIDAS, so we are established in 1989. So we have almost today 120 distributions in around 120 countries worldwide. So coming to the number of employees, we have more than 500 number of employees working with us. And considering number of clients, so we have almost more than 20,000 number of clients as far as now. Considering the distribution of the licenses, I can say we are quite successful in distributing more than 40,000 of number of licenses worldwide. So coming to our MIDAS family program. So we have all the software solutions for your bridges, structures, geotechnical, as well as mechanical solutions. So coming to the bridges, we have two packages. That is, one is MIDAS Civil, which is integrated 3D FEM software, so an integrated solution system for your bridges and civil structures. Then we have MIDAS FEA, which is advanced non-linear and detailed analysis system. Then coming to the structures for a building particularly, we have integrated MIDAS 10, which we call as MIDAS General. So it is particularly for buildings and general structures. Then coming next is MIDAS T-Shop. So it is particularly for auto drafting and rebar detailing module. And third is your MIDAS Design Plus, which is for the individual component design and detailing tool. Then coming to the geotechnical solutions. So we have 3D FEA based platform, which is completely geotechnical solutions, that is for GTS NX. And we have SoilWorks, which is for 2D FEA and both analytical geotechnical solution for their practical designs. Then we also have for mechanical aspects, like we have MIDAS NFX, that is completely a pre-processing tool, pre and post-processing tool. And we have MIDAS FX Plus, again for the nonlinear analysis. Coming next, talking about the features of MIDAS. So we have specifically specific functionality. For that we have static seismic load, integrated static seismic load. Considering we have response spectrum analysis, time history analysis, both linear and non-linear. Considering with your base isolators and dampers, which could be model. Then we have the non-linear static analysis stack, that is for completely dedicated for the pushover analysis. Then you have fiber analysis. Then we have a comprehensive capacity design as per Eurocode and other relevant codes as well. Then coming to the comprehensive design aspect, for the RC design, we have various national and international code integrated in the program, both for analysis as well as design. So as for that, like you have Eurocode, BS standards, Indian standards are also included in this program. So coming to the steel design, we have ASIC, then we have Astro LFRD, Eurocodes. So similarly for SRC, we have footing design as well as slab and wall design can also be carried out. Then for capacities design, you have Eurocode 8. Then coming to the high-rise specific functionality. So for that we have 3D column shortening effect reflecting the change in the modulus of velocity considering your creep and shrinkage effect. Then you have the construction stage analysis which needs to be accounted as far as your structural geometry is going to change, as well as the erection loads which are going to come up, that is also going to have effect onto your structure. So for that, why construction stage analysis is required, we will be looking into the program how importantly it affects with the definition. Then we have a very powerful integrated tool, that is building model generation wizard, wherein a typical story generation could be done, and after that you can very easily copy that particular story to other relevant stories. You can quickly generate other stories as well. Then you have this material stiffness change for the crack section analysis could also be considered in the program. So this is related to high-rise specific functionality. Then coming to the intuitive user interface, yeah, so I can say it's very user friendly. So coming to the work strap where all your powerful modeling capabilities, all the input information could be very easily visualized and could be defined with. Then again, you can change any of the particular geometry or the material property with a very greater speed so that you can very easily save your modeling speed, as well as you can very easily arrive at the design functions. Then coming to the flow load assignment, yeah. So flow load assignment is very easily applied onto the structure where we have directly integrated a flow load tab where the assignment could be sometimes become difficult when it comes down to circular or inclined plane. So thereby you can very easily assign those particular flow loads on inclined plane or any irregular surface. Then we have built-in proper section calculator wherein any of the built-up sections or any of the composite sections could be very easily modeled. Then we have very easy interface with the other programs, like we have interfaces with Tekla structure, Revit structure, as well as STAT interfaces, where you can very easily import or export any of the models from the same. Coming next, we'll be talking about the construction stage analysis now. Yeah, so in general, what we are assuming is the conventional method of analyzing is we are just assuming that the structure is casted at once and the load are applied at the moment, and we are just analyzing for the same. But in reality, all your construction sequence is going to proceed. So load effect, your structural configuration, the load patterns are going to change. Accordingly, it is going to have time dependent effect which will be relating to your material property, loads and boundary conditions are going to change. So how this construction sequence is going to affect your structure rather than going with the conventional method of modeling. So we'll just have a look one by one. Yeah, so talking about the conventional analysis and the construction stage analysis, what difference does it make this? So as we know today, so in the high-rise buildings, axial deformations of the columns we cannot ignore anymore. And we require a special consideration for the both design as well as construction. All right. So a vertical member, which as you know in the high-rise structures undergoes both elastic as well as your elastic deformation and deformation which is caused due to creep and shrinkage. So the elastic deformation takes place instantaneous, which may be due to the applied load as well as your whatever the loads which are coming onto the structures. Right. So, but whatever the loads which are coming due to creep and shrinkage, they occur at that many years. They are time-dependent loads which are applied on the structures. So most of the vertical deformations in the high-rise structures, however, take place during the construction itself. All right. So we'll just see these are two stages where we have very conventional analysis where we have a single-story constructions and loads are applied at once. But in the construction stage analysis where we have considered two stages, so in the first stage the one story is constructed and the load is applied. Again, in the second stage, 2 stories are constructed and the load is applied accordingly. So now we'll just have an interpretation about the moments. So as you can see, at the end, at the base of the structure, you can see this is, the moment is around 8.5 when you are going with the conventional analysis. But with the construction stage analysis, as you can see, the moment is increased at the base of your structure, right? So what considers this is because of just consideration of your creep and shrinkage effect as well as time dependent effect. But if this moment is in under the limit, then we can have various checks or we can increase the reinforcement. But if it is considering the high-rise structure, the moment is going to increase, right? So since we have considered only the 2-story structure, the moment is increased. As you can see, it is twice, right? More of less twice. But if it's more of the high-rise, then the moment is ultimately going to increase, where your section size is ultimately again going to increase. But for that, the construction stage analysis is very much required. So where actually the construction stage analysis is required. So in case of long span trusses, as you can see, as your structural configuration is going to erupt, the support conditions are going to change, right? So accordingly, it will have the effect due to construction stage load and the erection loads, as well as your span configuration, which is going to change at each and every point. Then again, you have for long span slabs, that is in case of bridges. Then again, the differential column shortening in the high-rise buildings. So differential column shortening is like whenever you have a change in the support conditions, loading, and the wearing material properties of the concrete. Now we'll just look into the column shortening and which are all the related issues associated with that. So column shortening, so as we know, so whenever any member is loaded with the axial load, it undergoes axial deformation, right? So this is the equation which we considered, that is PL by AE. So why this is important? This is considering a linear strain equations. So as you can see, more the height of the vertical member, more would be the change in the axial deformation, right? So special consideration needs to be met in order to account for the member of the component. Then coming to the differential shrinkage, so as we know, since our construction sequence is going to change and the loading area again changes, the tributary area for each column is going to change, so that the vertical member may cause the differential shrinkage due to the redistribution of the loads. But due to this, the differential shrinkage will come into picture, which may cause the additional stresses and the forces in the beams as well as your slabs. Then coming to the column shortening again further. So with the increased height of your structure, the effect of both the column shortening, if you are going to consider both in elastic as well as inelastic, so that added, that takes into the spatial consideration both in design and construction, right? So if you consider the different types of building, so it may undergo different shortenings. Say suppose if you are going to consider steel structure, then for elastic shortening, considering the 80-story, it is around 180 mm to 225 mm. But for concrete structure, it may be 65 mm, right? But if you consider at the time effect, both the total, if you consider the summation of both elastic as well as inelastic, so it may come around the same thing which would be accounted. But as interference, what we can say is your inelastic shortening is 1 to 3 times that of elastic shortenings. So coming to the issues which to be dealt with, so there are 2 basic prerequisites which needs to be accurately predicted and which needs to be accurately monitored. So these are creep and shrinkage. So for that we require reliable information and the characteristics of any particular concrete mix. So there are different codal provisions for predicting creep and shrinkage, different terminologies which are used. So program have integrated various codes as well as different methods for defining your creep and shrinkage properties. So we have ACI, Bazant-Beveja, then CBFIP, then you have PCM method, which are as per Marx Fintel, SK Ghosh, as well as Eurocode, and these are some of the methods for crediting creep and shrinkage. Yeah. So if you talk about the total strain at any point of time, which may be expressed considering your creep and shrinkage component, that is instantaneous strain, as well as your creep strain, as well as your shrinkage strain. So we'll talk about further more. So the instantaneous strain which occurs in the concrete, which may be expressed by the following relation, which is defined in the Eurocode, that is stress at any point of time divided by modulus of elasticity of the concrete at that particular time moment will give you the instantaneous strain. So this again, it is given by the following relation. Yeah. So you are talking about the inelastic shortening, which is caused due to both creep as well as shrinkage effect. So if you talk about the creep, you have the basic formulation. So as you can see, what is the formulation which is given by the Eurocode. So this is as per the creep coefficient given by the stress divided by the modulus of elasticity at a time of at that particular time. So these are some formulations as per the Eurocode. Then coming to the shrinkage, so basically there are two types of shrinkage. One is your drying shrinkage, which is caused due to the moisture loss in the concrete. Then one is the second one is autogeneous shrinkage, which is caused due to hydration of cement. Again, it is combination of both will give you the total shrinkage. Yeah. So what are all the different factors which mostly affect the creep and shrinkage of the concrete, the material properties of the concrete? So basically considering the material concrete, we have the concrete composition, so which will be cement pitch content, water cement ratio, mixture proportions, the aggregate characteristics, degrees of compaction that affect with the concrete material properties. Then again, initial curing also affects for your creep and shrinkage effect, such as your length of initial curing, then you have curing temperature and the curing humidity. Then coming about the structural geometry and the environment conditions. So in the environment, you can find that the temperature conditions and the water cement ratio. Then geometry, you can size the shape and size of the section that affect. Then the loading history, as far as the erection loads are concerned, the construction age, what is the application of the load, the duration load period, and the unloading period, and the number of load cycles do affect your creep and shrinkage of the properties. Then again, coming to the loading, you have the stress conditions, that is the type of stress and distribution across the sections. You have the stress ratios. Then the effect of the column shortening on the various structural and the non-structural members are considered. Considering the non-structural members, you have the effects on pipes, the elevator rails, claddings, as well as there might be cracks in the partitions also. Coming to the dealing with the structural effects, so due to column shortening, there would be distorted slabs or beams due to different differential movements. So because of, again, the gravity loads also come into picture, the superimposed dead loads, which also affect your column shortening effect, which may undergo cracks at the ends as well as at the center of your slabs. Then again, coming to the sequence part, so in the majorly in the column shortening analysis, we are just considering with the pre-slab installation shortenings and post-slab installation shortenings. So in the pre-slab installations, we have that the shortening of the supports which takes place at the time of slab installation. So prior to the slab installation, whatever the loads which cause the shortening that are categorized as pre-slab installation, and the post-slab installation shortenings are something that are taken place after all your floor finishes and the superimposed dead loads are taken place, which cause the post-slab shortenings. Then coming to the compensations for the differential shortening effect. So like for considering the reinforced concrete structures, so pre-slab installation have no importance herein, because the compensation is already done by the leveling of the formworks. Then the post-slab installation shortenings are due to subsequent loadings due to creep and shrinkage. So coming to the steel structures, columns are fabricated to the exact length, more of in the steel structures when you're dealing with the steel structures. So attachment to the supports are directly to the slabs. So pre-slab installation we need to know, because if the member is having the irregularities or the short of the length or the more of the length, so that also again come into pictures. Those needs to be considered in the pre-slab installations. Then coming to the compensations, that would be done considering both pre-slab as well as the post-slab shortening. So it will be summation of both the things. So here we do have to consider the pre-slab and the post-slab consideration and the compensation which is done in case of different types of buildings. Then what is the procedure of actual column shortening? So we'll just have a look. So for the procedure considering the column shortening analysis, so we are just carrying out a pre-analysis considering your material, section properties, loads, as well as the construction sequence based on the codal provisions. Then again, you'll be considering with the preliminary analysis, which is caused due to load distribution and again with the differential shrinkage. Then you will be checking with the construction's column shortening analysis graph. So if you're going to have the more shortening effects, again the experimental test data would be again support you for that, like compressive strength, whatever the checking with the modulus of velocity, again with the creep shrinkage, thereby updating all the material properties by the experiments, and all the things would be consideration, like the construction sequence, which is more important in case of your field conductions. Then again with the updation, again you will go with the more predictive methods of defining with the stages and updating with the creep shrinkage parameters. With the following that, you need to come into measure at actual site using the strain gauges. You need to also check with that what are all the actual site shortening effects that are done with the analysis, and then after that predicting the same comparison of both the field as well as your analytical, then you can again apply those particular applied results onto the field. So coming to the project applications, yeah. So in the project applications, as we know, the Burj Khalifa MIDAS chain has been used for both analysis and the column shortening effect study. So as you can see, the height of Burj Khalifa 705 meter, having 160 floors. So it was built by general contractor Samsung Development. So there has been used for the column shortening effect study. Then coming to the next example, that is SK Junior in Seoul, South Korea. So where we have the number of floors as 36, each floor having different shape and the various structural configuration. So it is both composite structure, considering your RC core, you have steel as well as your RC composite frames structures is also integrated with that. Then you have again the Canman Hanoi Landmark Tower in Vietnam. So these are basically the Twin Towers which was constructed. So in the 4 towers were of 49 floors and the mid tower was 70 floor, which was again completely a RC structure where the column shortening effect has been carried out in MIDAS chain. Then coming to the procedure of column shortening. So first of all, we are defining with the material properties and the section properties in the program. Then we are defining with the elements like all your structural configurations, boundary configurations, and the loads to the groups. So for as we know how the construction sequence affects your loading. So all these things we need to categorize prior to the analysis. The third stage would be defining your time-dependent material properties. So what are all these time-dependent material properties? First is your creep and shrinkage. Second is your compressive strength. So let's say, yeah. So let's go to creep and shrinkage. So yeah, so for the defining your time-dependent material properties, we have integrated module for defining both creep as well as shrinkage in a single tab. So as we know, creep effects of the concrete member have the different maturities. Accordingly, the creep is going to change. Similarly, shrinkage effects of the concrete is also going to have different maturities. So again, the third point is your consideration of your compressive strength. That is again the member as your days increases, your modulus is going to change. The compressive strength value is also going to change. So as you can see, there are different various national and international codes which are integrated in the program to consider for the same. Yeah, so coming back, so after definition of your time-dependent material properties, then you will be going with the construction stage analysis data input. So in the construction stage definition, you will be specifying all your construction stages depending upon the duration. So let's come to construction stage definition. Yeah. So there is a integrated construction sequence to be defined. So program allows you to consider various stages for the definition of your construction stage analysis sequences, where you can very easily specify the number of sequences and the stage duration. Program also gives you flexibility to define various number of stages considering within a single stage. So if you are going to have a construction stage duration which is lasting for 10 days, so additional steps you can very easily define within that particular construction duration. Again, you can very easily formulate or tabulate into the tabular form where program will give you the definition in the actual format. So that would be very easy in interpreting with the construction sequence interpretation. So coming back, so after definition of your construction stage analysis data, you'll be going with the analysis. All right. So after the performing analysis, you'll be going with actual result interpretation with the each and every construction sequence. All right. So after that, you'll be going with the column shortening analysis, generation of all the results for the column shortening analysis. So yeah, so this is all regarding this. Yeah, coming to the talking more about the construction stage analysis in the program. So there are basically three stages. So one is your base stage. So in the base stage, there will be defining particular structural configuration, boundaries, and the load groups. So considering your first sequence, you will have different structures. So again, it will have the different structure group. Then again, you will have different boundary groups as your loads is going to change. You will have tentatively different load groups. And the construction stage. See, this is particularly for performing the construction stage analysis and activating those particular relevant structure, boundary, and load groups into that particular construction sequence. So thereby you can activate and deactivate certain boundary groups, load groups, and structure groups in the certain construction stages. And that same could be checked for. And we have the third stage, that is your post-construction stage. So that is to interpret the transient loads which are coming other than the construction stage loads, as like your superimposed stage loads and various other loads that could be accounted, like your wind and system, for example. Then coming to the interpretation part, yeah, so various analysis results can also be checked for each and every construction stage, as that can be checked. All right. Then again, the absolute and maximum and minimum results and the envelope could be checked for the entire construction stage. Okay. So program does provide the results for your creep and shrinkage effect was also provided. So as you can check, what are all the displacement due to creep and shrinkage which is occurring with respect to construction stages or at the end of the stage that could be observed. Yeah. So there are the column shortening graph which are obtained in the program considering various loads and various construction stages. So let me take you through the actual demonstration part, so to get more into that clarity. So I will just open the program now. Yeah. So this is the interface of MIDAS Gen. So as you can check. So coming to the main tab, so here as you can see, I'll just quickly get you through the graphical user interface of MIDAS. So as you can see this, all the main tabs are arranged or streamlined in a modeling workflow as the engineer proceeds with the modeling. So this is very easy for him to model with, like you have structure tab, node element tab, then you have property tab, you have boundary definition, then you have loading configuration and the analysis respect. So after the analysis, you'll be going with the results, and then again you will be going with the designs part. So let's coming to the main important feature of MIDAS Gen. So you have this import export capability which is very well supported in the program. So in the coming to the import tab, you have various other programs which are very well supported. So as like you can very easily import any of the program file into the model, as well as you can even import the AutoCAD file and creating different layers into the program. And similarly, you have the export feature wherein you can create or extract your result to AutoCAD, and even you can make it as an input file over here. Then again, you have this particular tree menu. So tree menu is something that all your working window or the working definition would be appearing over here. This is completely your model window, and this is your message window where all your analysis and the error message would be displayed. So this is all particularly for your definition and generation of your story. So we have various base structures which are like you have beam, column, arch, frame, truss, plate, as well as shell model wizard that could be used. Again, we have also integrated this tower wizard for the generation of your tower. Right, so you can also check with that. So let me show you with this. We have again the building generation capability. So here we can very easily quickly generate a building. So let me show you, considering an example, how quickly you can replicate all your stories. So I will just come up with the frame. So I will add few, like with the frame generation, you can specify the distances. So let's say I'm considering a spacing of 3 meters, and I'm just repeating it 6 times. I'll add coordinates. Again, I will same consider, let's say I'm considering 4 divisions over here, and I'm considering the repetition to be again 6 times. We'll add coordinate. So I can go to edit tab and make it a generate frame. So that particularly I can make a frame over here with a very quick insertion. All right. So now I'll just try to insert those particular frame into my model. So this particularly I can very easily quickly generate particularly my frame over here. And now if I go to building generation, now here I can very well generate my particular relevant story. So I have various different tools also available with me, like I have various CAD tracing tools for node and element consideration. So I can very well use this function to generate all my elements. So now I can just specify the distances for my generation of my column. Let me take into this. So all this. So now I have created a typical story. So I can just switch on between the various views. Now let me take you through the capability of generating the building generation wizard. So now here you can very easily generate all your building story. So now as you can say, I have generated this particular typical story. Now I can create multiple, I can replicate number of copies considering the distances. So let me consider 4 meters at the height of story. Then I can add this. So I will add this, and I will just select this typical stories using selection option. So I can directly go to this, and I can use this select all option, and now I can apply this. So this is how we can very quickly generate any of your geometrical configuration if you have very well structural plan with you. Even your structural plan also supported using import function where you can quickly integrate those from the AutoCAD DXF also. Yeah, so there is one question I'll be addressing at the later point. So let me take this. Yeah, so various plans could also be imported from that. All right. So this is regarding the generation of your model. But let me take you through now. This is just to project the capabilities how you can quickly generate all your material properties. So coming to the section database, I just wanted to show you how the different section database are considered in the program. So these are various section database. So we have various section shapes which could be also be very easily defined. Then you have this value type of section where you can very easily specify the number of values, user defined sections. Then you have also the composite sections which could be defined. So considering the SRC sections, so we have different section shapes that are integrated. So you have this SRC box, SRP pipe sections. Those sections you can very easily define with. Even you can define with the composite sections. So I have various composite sections. So if you not, you can very easily import those sections into the program. Again, considering the non-prismatic sections, yeah, so non-prismatic sections could also be imported into the, also be defined into the program. So this is regarding all your material and section definition. So now let me take you through the model where I have created, already generated a model. So I'll just open that model. Yeah. So this is particularly one model which is considered for your column shortening study. So I have already generated that. So this is my typical model which is generated. So considering the number of stories. So let me take you through the interface. Yeah. So this is basically the number of stories which are defined. First of all, if you come down to Works tab, as I have already discussed, Works tab is very intuitive where we can find each and every definition which could be defined into the program. So as you can see, there are various material properties which are defined considering your girder and beam elements, and you have different section assignment for your wall. Right, so if you just check, this is all your shear walls which are considered for your vertical circulation system, that is for your elevator and everything. Then you have various time-dependent material property definition. So for the time-dependent material property definition, you have this creep shrinkage as well as compressive strain definition integrated in the program. Apart from that, you can very easily user-define those particular material properties. So let me take you through the creep shrinkage definition. So I'll just tell you how we can very easily integrate or define the creep shrinkage parameters into the program. So for the creep shrinkage consideration, you can very easily go with, so let's say I'm just giving a name over here. Now you can choose the various relevant code that are integrated. So there are various national and international codes. So we have Indian codes as well as various Euro code also integrated. You can just define accordingly. So as you can check, so at point you can just specify. Let me change with the unit system. Yeah. So now I can add this. So let me give M35, considering the material properties you can give. So you need to enter the site relevant parameters such as like whatever the characteristic compressive strength of the concrete which should be entered. So I'm just considering 35, right? 35 MPa would be consideration. And I will just accordingly enter the relative humidity for the ambient temperature, ambient environment. Then I would be entering a notional size of the member, which is dependent upon the sectional size. Since priorly I'm not knowing with this notional size, I can enter a very arbitrary value, which is 1 meter. So program will automatically update all your notional size of the member using change property option. So now you can just check your creep shrinkage graph. So program has generated the initial creep coefficients values for your start loading and end loading. So considering the number of steps, so steps are nothing but you have generated from this particular start to end, you have generated in between 24 number of steps for your creation of your creep shrinkage values. So you can check, even you can check with the shrinkage strain as well. So shrinkage strain also we can interpret with the various values. Okay, I'll close this. So accordingly, you can go on defining the material for time-dependent material property for creep shrinkage. Then again, I will go with the compressive strain definition. So for the compressive strain definition, I will just try to add one this. So here you will just provide a name as M35 again. Then again, for the development of the strain, you will be considering with the various codes. So again, you can choose between the various codal standards for the generation of your compressive strength values. Then you will be entering the mean compressive strength values considering the standard deviation. So that could also be entered into the program. So in just considering 10 MPa standard deviation. So accordingly, you can redraw the graph and you can very easily generate the compressive strength definition. Then coming down next, yeah. So these are all your material properties have been linked with this. So let me change with these properties. I can just go to change property option, and now I can very easily update all your notional size of the members. So I will just click on apply. Alright, now you can check in the tabular form how your notional size for each and every member could be updated. Right? So this is the notional size which is calculated by the program for each and every individual element. Alright, so now coming next, you have the section definition. So as you can see, there are various sections which are defined. So the girder sections, the slab sections, right? So now at any point of time, you can just check you can change any of the section properties right from over here. So if you like at any point of time, if you wanted to define, like if you wanted to change any of the parameters, then you can just change that particular shape or can directly drag and drop into the model window. So this is particularly for my definition of my shear walls, the beams. So you can very easily select any of the relevant standards and you can directly drag and drop that particular relevant material property into the model. So that accordingly program will change the section at that particular location. Alright, so let me go further. Yeah, so this is the section definition, thickness definition which we have considered. This is particularly a plate model. This is the for generation of your particularly the shear walls which we have modeled. So we have given the thickness as 0.3 mm. Then we have provided the releases at certain point of time. Then we have assigned the support conditions which are at the bottom of your supports. Then we have converted load to the masses. So there are various loads that are defined, like you have dead load and live load which are defined, right? So as you can check, so there are dead load, live load. So floor loads have been assigned using this floor load option over here. So you can very easily assign the floor loads also into the program. So let me display this. Yeah. All right. So now this is typical generation of my particular frame. Then I can go to building model, then control data, and here you can very easily automatically generate all your story information. So story information is automatically considered into the program. So one more advantage over here is your consideration of the floor diaphragm. So at many point of time, there are various tedious tasks to find off your center of mass, then again connecting all your diaphragm exterior nodes with the center of mass with the rigid links. But in the program, if you are able to consider with this, you can directly specify where you need to consider with the flow diaphragm. So program will automatically connect all your periphery nodes with the center of mass through rigid links. So this particularly consideration, you can make it in the automatic generation tool. So various eccentricity values would be calculated by the program for your generation of your automatic wind load as well as static earthquake load generation. So as you can check into the load tab, so where are all the various loads that have been assigned. So considering the wind load. So as you can check, you can automatically assign all the wind loads. Let me drag this. Yeah. So we have various codes. We have IS 875 also as per the new revisions. So this you can just find out the basic parameters you can input, and you can just try to generate all your wind profile. So even you can just copy this particular wind calculations to different calculation sheets also. So as you can check various different shear force, story force, as well as the overturning moment for your wind load calculation. So program will give you effective the pressure values and the elevation and the loaded information for each and every story and each and every direction also. So similarly for static earthquake loads, so you can seismic loads could also be very easily defined, and similarly the profile would also be created. So I've already defined into my model. So it's just an input which we need to give over here. All right, again you can very easily generate those particular wind profiles over there. So let me show you this wind profile. So again, you can see this seismic wind force at each and every story. So program will calculate all the story shear forces, story shear, as well as overturning moment. All right, so let me go further now. This was all regarding the definition into the program, how you can very easily consider various seismic loads over here. Yeah, coming back to the topic, we have this construction sequence which needs to be followed. So we'll just have a look of this, how this construction sequence is followed in the program. So let me minimize this. Yeah. So coming to the construction schedule, so we have 3 levels of shoring. So for the construction cycle time, we have 7 days. That is, we are considering the time of removal of the lowest level of the shores to the concreting of your top floors as 5 days. So in the first stage, we have the formwork installation, and second, with the third day, that is prior to after the 2 days, our concrete first level slab is casted. Again, where we have the age as 0 day, we can consider this as 0 day. Then again we have second floor, which is considered as after consideration of your 5 days. We have that is on the 8th day, which is again the formwork installation for the second story is being constructed. Then again with this we can say after the 10th day, that is after the 7th day, we have the second floor constructed, that is the slab is being casted at the second stage. Then coming to the next schedule, coming to the third floor installation, that is begin after the 5 days. So that installation has been done, and again with the casting of next 2 more days, the third level is also being casted, where your concrete age of the member we treat as that 0 days. Likewise, if you just go on with the search sequence, so again with the coming next 2 more days, that is on the 22nd day, the fourth story is also constructed. Fourth story is also constructed, where again with the similar stage we have the removal of the formwork for the first story, right? So at this particular point, the member age of the concrete that is on the 22nd day, and it has been started on the 3rd day. So total duration of the member age becomes total 19 days. So this is the age which we will be considering into the program, which will be defining into the program. Likewise, you can consider the various sequences for your construction sequences. Yeah. So this is the construction schedule which we are following. So considering the 12 number of stories, so we have such sequence associated with, and these are the duration which we'll be considering. So for each stage duration, we have different formwork activities, the construction activities, which will be accounting. So as you can see, with the construction of the 12th story, we have the removal of final story, removal of the final formwork, and the application of subsequent superimposed dead load, which is again considered at the 71 day. And after a few more days, like again after the end of the after the application of your SIDL, the live load is being applied at the 112th day. So this particular age duration which will be directly accounting into the program. So let me go back to the program and just try to focus how we can define with the program construction stage definition into the program. So here we can directly go to load, construction stage load, and you can define various construction stage load. So in the defined construction stage load, you need to manually input all your structural loads, elemental loads, and the load configuration which is going to change. So those particular definition could be very easily given into the program. Then again, the additional steps you can very easily create. But now we are not going to manually assign all the properties. So we are just use the very powerful tool, that is your construction stage wizard. So in the construction stage wizard, you can very quickly generate or automatically generate all your construction stage duration. So as you can check, program will automatically create all your groups which are associated with this. Let me try to use this wizard. So with the automatic generation, you'll be directly giving with the construction stage definition. The superimposed dead loads could also be considered. So in the construction stage load, we'll be considering with the dead load. All right. So your story increment refers to the number of stories which are being casted at once. So we have considered this to be 1, the story increment which is going to be casted. Then you have the stage duration. Stage duration is nothing but your the time lapse which is going to take place for each and every stage. That is, we are considering with the 7 days. That is 5 days we are considering for the all the application of your form work load, and the 2 days for your removal of your form work. Then member age is nothing but the attainment of the state right from the time lapsed between the installation of your form work to the removal of the form work will be the age of the member, which would be entering as 19 days as we have seen in the definition. So this is considering your dead load. Again, various superimposed dead loads could also be accounted into the program. So let me consider with the very first superimposed dead load. So I'll just consider with the flow finish. So in the flow finish, again, I will consider this to be accounted, again, considering the 3 number of stories. And then I will just define the starting day. Starting day is nothing but when my all the superimposed dead loads are going to be accounted. That is on the 71st day, which is going to be applied. And the day increment is nothing but your 3 days. Like with the 3 days, each your story is going to be casted. So that accordingly this flow load would be applied onto the relevant stories. Then again, you can also consider live load into account. So I have considered this live load also. Now you can specify the live load application. So here you can define 3 stories. Again, the starting day would be 112 day, where your actual live load would be actual when your building is constructed. And this day increment is no matter, no importance, you can consider as such. So you can generate. So as you can check, program have generate various construction stages considering all your stage duration as well as your member age. And again, program have also defined various superimposed dead load sequence into picture. So I just click on OK over here. So now as you can check, so there are various construction stages which are defined into the program. So if I go to CS1, only the first stage would be activated. So if you go to groups, so in the tree menu you can see only your dead load is going to act onto the structure since only my first construction stage had happened. Then again you have in the CS2 the next story would be constructed. So likewise you can go on defining the various structural configuration accordingly, right? So this is how you can go with the definition and the actual generation of your construction stage definition, right? So now let me try to define one more stage over here considering the long term to account for the creep shrinkage effect. So as you can check, we have just generated the data till only 115 days, right, for the cumulative 115 days. But let me try to add one more stage over here manually just for the consideration of creep shrinkage. So I'm just considering a 3 years period for checking of your creep shrinkage effect. So let me try to enter the days as 1063. So I will not activate any of the element boundaries and load over here. So I will just click on OK and generate the respective construction sequences. All right. Then this is how you can consider with the various construction sequences like program has generated using the construction stage wizard, the various construction stage definition. As you can, that could be checked into the tree menu, right? So let me try to analyze this. I'll just perform the analysis. So program is running right now. So till then you can just check what are all the different definitions the program has generated, right, for your load and applications. So various static loads could also be defined, the various wind loads, the various live load. So these are basically assigned considering all your the direct generation, where you can very easily define the flow load option. You have the various flow load options for the assignment. All right, so if you again coming down to one more definition, the construction stage definition. So in the construction stage definition, you can very easily very well specify where if you wanted to check for the relevant stage, like at any point of time you may not be required with the complete stage analysis. So if you wanted to perform at the any intermediate level, like say suppose if you wanted to know only the results up to CS3, what is the actual shortening which is happening at CS3, so you can just specify that particular stage at like if you wanted to run the results only for that particular stage, accordingly you specify CS3, then you will run the analysis and the program will perform only up to that particular stage. So if you're considering with the last stage, program will consider all the accumulative stages and give you the results for the final stage. Then you have the analysis option over here. So in the analysis option, you have various linear and non-linear analysis option that could be given for the definition. Then the time-dependent effect control definition, you can very easily specify the creep shrinkage parameters for your consideration of your column shortening effect, wherein if you wanted to consider only for creep or only for shrinkage, so that would also be accounted. Then you can also specify for when you are for your post-tension slabs, if you wanted to check for the losses, that could also be checked. Can that elastic deformation loss could also be accounted for the same. Then you have the composite section. Yeah, if you use the composite section, the each and every section, your results would be interpreted differently. Then you have the load cases to be distinguished from the CS loads. So for the construction stage output, if you wanted to differently look for the results, like for you, if you wanted to make live load differently, if you wanted to check for the dead load of like other superimposed dead loads that needs to be checked, then accordingly you can specify those in the program. All right. So this is how you can very easily define the construction stage sequence in the program. So again, this is all relating to your construction sequence definition. So if you just check for each and every definition, if you are going to consider, one more thing over here is consideration of your construction stages when it comes down to composite section definition. So in the composite section definition, you would be requiring to define with the various stages. Like if I come down to definition of this, yeah. So you can very easily specify the sequence of the composite action, like when is your concrete and the steel which is going to be activated. So accordingly, you can also create various composite section shapes for your construction sequences for your construction stages. So those could also be accounted into the program. But it is just a definition which would be give a requisite, wherein you will be specifying differently the parameters, the stage activation duration, as well as your composite action which is going to take place at which particular stage. So those things you need to very well account and define into the program. So let me go back to the program. So program has analyzed the structure. Now we can just go back to the result interpretation part. So in the results, so you can form the load combinations. So in the load combination, you can directly check. So we have this auto generation feature where you can directly create or auto generate all your load cases relevant to that particular codal provisions. So as you can check, so program has generated various load cases. Now you can check with the reactions. So different reactions could also be checked for various different combinations and load cases could be checked. So as you can check, so these are the various reactions. Let me try to check in Z direction. Yeah. So now we can even turn on this legend to see with the actual reaction values. Now you can even turn on the values in the graphical format also. So this could also be checked into the model window. So now again the deformation could also be checked considering the various load and load cases. And the forces could also be checked. For the beam forces, you can check with the shear forces as well as your bending moments could also be checked. So now you can check with the bending moment for the dead load. So if you are going to check for the dead load, you can select with the dead load and you can click on OK. So now you can check with the bending moment shapes the program has created. So now if you wanted to check in the construction stages, then you can go back down to construction stage for which you just wanted to check for the results. So if you wanted to check for this particular construction stage, what are all your bending moment values? So those could also be checked with, right? So such definition could get very easily checked into the program. So accordingly, you can check with the stage wise what are all the different effects that are coming into the picture. Then again, as we have discussed about this test, if you wanted to look for the transient load application, then you can very easily switch to post CS stage. So you can just go to post CS stage, check for the results. Yeah, so accordingly you can check with the stresses also. There are various beam stresses as well as the plate stresses. So check into the shear walls, what are all the different stress concentration which are occurring. So those could also be checked into the program. Then again you have the column shortening effect study. So this is a major effect. So program has directly the graphical powerful wizard. So for interpreting with the column shortening results. So we have graphs for generating all your creep shrinkage effect. All right. So I'll just try to generate all your column shortening graph. All right. So let me try to consider with a new column effect. So here you can directly add a new column. So let me try to generate the graphs for the same. So just so now here you can add up all your load cases and the columns which you need to account into. So you can just check up to elastic up to casting, elastic sub to casting, shrinkage as well as the total both, which includes elastic as well as inelastic shortening that could also be accounted. So those things you can check into the program which effect which you need, and you can give all your column information, that is the coordinates which you can very easily specify. Then you have the various construction sequence that could also be checked into, like if you wanted to check the results for all the things. So you can just turn on both for creep, your shrinkage, as well as elastic shortening, as well as the total shortening. Those could also be taken into account. So those things you can very easily specify considering the sequence, like the stages for which you want the results. So if you are just concerned about to check up after the 3 years or the relevant stages, so you can directly check accordingly. So you can directly click on apply. So as you can check, program has generated this particular time dependent effect graphs for both your creep, the elastic shortening, as well as shrinkage, as well as total elastic shortening effects values which are given into the program. So as you can check what is the maximum displacement you are getting at the very 3 years of span, considering all your creeps shortening as well as your elastic shortening, as well as your shortening due to shrinkage, as well as your total shortening, which is considering both elastic as well as inelastic shortening. So maximum the deflection, maximum shortening which has taken place is 0.0158 meter. So this is occurring at somewhere around 11th floor, which is taking place as you can say 0.0155 around in between that value that has occurring at this particular level. So this is how you can very quickly generate all your column shortening results just by selecting the construction duration and the output for the each and every column. If you want this particular graphical format to be saved in Excel, you can very easily generate the Excel report format, as well as you can just, if you wanted to include it in the report form, then this graph could also be included in the report, as well as the text could also be given from that. So as you can check, you can give the name over here, and you can very easily generate the Excel graph into particular model. So let me try to show you how the Excel values go into that. So now this is how you can generate the graph for the column shortening, whatever the effect that you have created or generated. So those could also be very easily plotted into the program. So that is, program has directly exported this particular graph into the Excel. So this is a very the interpretation capabilities program has. So yeah, coming back again down this, so we have seen how we can quickly generate with the various result interpretation as well as the column shortening study. So let me go back to the presentation part. Yeah. So coming to the discussing about the more useful features for the construction stages. So we have this powerful construction building wizard, which we have seen how we can very quickly generate the story definition considering all your sequences. So it will allow you various different time elements to be created for the loading application and the construction stage duration definition for the erection of your building. And again, you can find it more convenient for generating all your stages rather than defining each definition individually. Then again, consideration of your SRC sections, that is your composite sections. So in the analytical procedures for each and every construction sequence could also be simulated in MIDAS chain just by activating and deactivating various boundary groups, your structural loads, as well as all your structural configurations. So those could also be simulated in the program just by specifying your composite sequences, like when you your first part activated, your second property activated. So program will accordingly take the transform stiffness. So composite stiffness could also be taken into account, and different stiffness scale factors could also be given. So this is how you can very easily simulate into the program. Then you have material stiffness changes, which could be very easily accounted for the crash sections. All right. So these sections are integrated in this. Yeah. So as you can check, for each and every stage, you can specify different scale factors where your crash section properties needs to be accounted. So yeah, you can just check where your flexural stiffness for your beams and walls that are reflecting your crack sections, those could you can simulate. So as you can check, there are different multiple scale factors which could be specified. Then again, yeah, coming to the spring supports for your soil structure generation, yeah, MIDAS have very powerful integration of the integral bridge wizard for your generation of your abutment springs as well as your pie spring generation. So we have various linear compression, tension, as well as the multilinear springs, as well as surface springs could also be defined into the program. Yeah, coming to the tendon loss program, we can very easily define all your pre-stressed load considering your construction stage analysis, or both your tendon primary as well as the secondary forces could also be extracted in the graphical form, as well as your tabular form could also be extracted. So where in case of your post-tension slabs, so where your tendon definition could also be given into the program. Yeah. So thank you everyone. So this is how I have ended with the webinar. So if you need any further assistance, you can kindly mail us down onto the globalsupport.midasuser.com. So this is our global portal over here. So at the end, you can write out down if you need any further assistance.